Okay, for the second example, we've got a beacon, which is out in the water maybe somewhere on a rock or something. And it's located a perpendicular distance of 315 meters from point R. So the picture's here to just give you an idea. And then its beam of light is sweeping across the shoreline. And as it gets further away, it feels like it's going at a different speed than right close at R. So we want to know how fast that beam of light is sweeping across the shoreline at the point S. And so in the picture that's given, there's point S. But you'll notice my beam of light hasn't gotten there yet, and it will in a second. The other bit of information we know is the distance between R and S is 425. So I'm just going to, actually, no, well, yeah, no, I'm going to redraw a picture over here. So here's my shoreline. I've got R here, and I've got S over here. And apparently, at this spot, at the time that we're evaluating it, this is 425 meters. Remember, it doesn't stay 425 meters, but that's just that one spot. This is out here, and this I'm just going to call B for my beacon instead of trying to draw a picture. And there's my ray of light, which at this snapshot is exactly right at S. This is 315. That's going to stay the same. Of course, that's going to be perpendicular. It says that it's a perpendicular distance. I've got this third side here. I need a letter for it. I like H. I think it's a great one. Yeah, it's a good side. Good. Okay. And the other thing that we have is this rotation. So which angle at R, at B, or S, which angle describes the rotation? Where does that exist? At B, that's right. Okay? And it's going in 1 revolution per minute. We're going to have to deal with that in a moment. So just like with the other question, we're going to write down all of the sides and their corresponding rates of change. So let's choose, let's give these other ones letters. I'm going to call this one X, and I'm going to call this one Y. Actually, I'll just put the X inside so it's a little easier to see. So I'm going to call this side X and this side Y. So starting with X, at the snapshot is actually 425. dx by dt is how fast it's going along the shore there, and we don't have that information yet. We may or may not need it. Actually, how fast does the beam sweep across the shoreline? That's this, right? How fast is this X dimension moving? How fast is that changing? So that's actually my unknown. So we're going to definitely want to use that side. Okay, we also have Y, which is 315. And dy by dt is 0 again. That's right, because the beacon doesn't move. So this side here is going to stay the same. So dy by dt is 0. We've got 2 other unknowns. We've got h, which I don't know yet. I may or may not need to. And we've got dh by dt. Again, I don't know if I need that yet. What's the other variable in the picture? Theta. And then d theta by dt. Now, one of those we actually know. It does tell us how fast the theta is changing. It says 1 revolution per minute. So I'm just going to put this up here. So this says 1 revolution per minute. Now, we'd like to talk in radians. So how far is 1 revolution in radians? 2 pi, good. So this, we actually know, is 2 pi, oops, 2 pi rad per minute. So we're going to use 2 pi instead of 1, okay? All right. Now, we may need to do some more work later on to figure out h or dh by dt or theta or whatever. But let's not do work that we don't need to do. We'll pick a trig ratio and then differentiate and find out which ones we want. So again, if you remember my advice from the last question, we pick a ratio that's going to use the fixed side and the rate of change. Okay, a known rate of change. Well, the known rate of change is the theta part. The rate of change I need is x. So again, I'm going to pick the x side because it's the rate of change that I actually need to figure out. The theta is in all of these. It happens to be my known rate of change. And I can either use y or h. Which one am I going to use? Y, because it's my fixed side. And remember, that's going to make my life a little bit easier. So, if I'm using theta and I'm using y and x, turns out I'm going to use tan again. Now, it's not always going to be tan, but in this case, in these two, it has been. So I'm going to use tan theta as x opposite over adjacent, so it's going to be x over y. Again, before I differentiate, I'm going to fill in stuff I know. I know that y is 350, and I know that x is 425, but I'm not going to plug that in yet because I have to differentiate it first. Okay, so remember, this x changes, so I don't want to say that x is always 425. It just happens to be 425 at that moment. So I'm not putting in x yet. But y is always 315, doesn't matter. Again, like the other question, I'm going to make it just slightly easier by bringing the 315 up here. And now I'm ready to differentiate. Again, we're going to differentiate tan theta, which is secant squared. I'm differentiating with respect to t. So I need to add a d theta by dt. The right-hand side is x. I take the derivative of x, which is 1, dx by dt. So good news is my dx by dt is there, and that's the thing I need to find. So and it's actually isolated by itself, so the math's going to be pretty easy. What I'm now going to do is figure out secant squared theta and d theta by dt. Well, actually, d theta by dt I know, right? D theta by dt is right here. It's 2 pi. So secant part I don't know yet, but this part I do. And dx by dt is what I need to figure out. So all that's left is trying to figure out the secant. Well, again, I'm going to go off to the side and try and figure out the secant. The secant is the reciprocal of which side? Cosine. So I'm going to find the cos. The cos is adjacent over hypotenuse. So again, looking at my equation, cos is adjacent, so it's going to be this side over hypotenuse, which is already labeled h. How convenient is that? So it's x over h. The x part I already know. Or no, sorry, not x. It's y over h. Sorry. The y part I already know is 315. Oh, man, I wrote it down wrong again. Sorry. Y over h. The y part I know is 315. The h part I got to figure out. Well, that shouldn't be too much of a challenge in this question. The h part is right there. I'm going to do the math right here. I'm going to go h squared equals, well, 425 squared plus 315 squared. You can punch that in your calculator, 425 squared, get a big number, plus 315 squared to get a big number, add them together, get a big number, take the square root of it, and off the top of my head, that's 529. So now I have the h part in my ratio, 529. That's great, except I don't actually want cosine. What do I want? Nope. I want secant, right? So secant, if that's cos, what's secant? Reciprocal, 529 over 315. And that I'm going to plug in here. So secant is 529 over 315. The only catch is it's not secant, right? It's secant squared. And if you look at this, I actually have all of the information now that I need to solve. These are all numbers. So now it's a matter of plugging that in my calculator. I can make it a little bit easier if you wanted me to be as slick as I was last time. 529 squared over 315 squared, 2 pi equals dx by dt. Since I've got a 315 here and a 315 squared, that actually is a little bit easier. I wouldn't, you don't necessarily need to do those steps. You might go right to your calculator. And have a little bit of work. Oh, by the way, well, it doesn't matter. Pi, you're just going to use in radians or degrees. It'll get you the same number. But if you did end up with any angles in here, make sure we are talking radians. So your calculator should be in radians. But anyway, we get 5,581.9 meters per minute. That's how fast the beam of light is scanning across the shoreline. This one's in meters per minute only because the question gave me revolutions per minute. So I had rads per minute. And the last one I was in seconds, so it was in seconds. Okay? So the goal in all of these, it's the same as the applications we did before, is come up with an equation, differentiate, find any of the variables that we need to off to the side, and then plug them into the equation. So you have this worksheet to attempt and try, and hopefully the questions on it are similar to the ones we did today. So good luck.